Hi everyone. This is not a video about learning to find the distance from a point to a line. I'm going to assume that you're already familiar with that process. Rather, this video is about using the calculator efficiently to solve one of those problems. After all, you've purchased a nearly $200 calculator. Why not get the most out of it? So to briefly summarize, to find the distance from the point -3, 7 to the line, y equals 5/3 x minus 4, it's basically a three-step process. I'm going to find the equation of a line that's perpendicular to the line given that passes through the point -3, 7. Then I'm going to find the point of intersection of that perpendicular line with the line given. And then I'll use the distance formula to find the distance between the point -3, 7 and the point of intersection that we just found. You'll see that if you use your calculator efficiently, there's very little work that you have to do by hand. In fact, there's no work to do by hand in this particular problem. So, let's get started. I'm going to need to find the point of intersection of a couple of lines, and to do that, we press Menu, Algebra, Solve System of Equations, and since we're dealing with lines, I can solve systems of linear equations. I follow the on-screen prompts. I'm just dealing with two lines, and the variables x and y are perfectly fine. So, I type my equations here. So one of the equations is the one that's given. Y equals 5/3 x minus 4. So if I want to use a nice fraction, I can use the template, I suppose. Y equals 5/3 x minus 4. So what about the other equation? Do I need to do a bunch of algebra on paper? No, absolutely not. I just have to remember that the slope of this perpendicular line that we're looking for is -3/5. That's the opposite reciprocal of 5/3. If you were to write the equation down on paper, hopefully you would write it in point slope form. Y minus 7 equals, now I need that slope, -3/5. So if you want this to look nice, you can say, use the fraction template, -3/5 times x minus -3, we'll make that x plus 3. The calculator is perfectly capable of dealing with point slope form. There's no reason that I need to do any algebra here. So what I've done is I've taken the first two steps of the process for finding the distance from a point to a line, and I've offloaded all of the work to the calculator. So I found the equation of the line, y minus 7 equals -3/5 times x plus 3, and then the linsolve command is going to give me the point of intersection. So there we go. If you don't want to deal with those fractions, I can just press Control Enter again. So now we have the point of intersection, 4.05, 2.76, if we're going to round a little bit. And now I'm going to use the distance formula. We want to find the distance between this point and that original point that we started with, -3, 7. And I can type the distance formula in one step in the calculator. It's the square root of, let's see, the x-coordinate of the original point was -3. So -3 minus 4.06, if I want to round to 2 decimal places, squared. So that's x minus x squared, plus the y-coordinate was 7. So 7 minus 2.76 squared, and I'm done. This will be the distance between the original point and the point of intersection of the line and its perpendicular line. So I press enter and I'm done. The answer to this question is about 8.23. See how fast that was? If you use your calculators efficiently, you can really narrow down the amount of work that you have to do by hand. Now, if you are doing this question on a test, of course, you'd want to show a little bit of work, perhaps write the equation in point slope form, and then write down the point of intersection, and then write down the distance. That's really all you need, though. So, I hope this video was informative, and just remember, when we use the calculator in class, we want to get the most out of it. We want to use this as we want to use the calculator as efficiently as we possibly can. So that's the end of this video.